Okay, perfect. Okay, Misa, you can start whenever you want.
Okay, cool. Let me share my screen. Mm-mm-mm. Guys, do we have the screen shared?
Yep.
Do we see it? Because
Yeah.
sometimes when
Yes,
I
yes,
when
we
I
can
share
see.
it, I don't see what's shared. I need to employ another monitor for that. But
Yeah,
yeah.
we're seeing the
Yeah, we're
present.
able to see.
Okay, super cool. Hello everyone, ZKGM or KZGM for the KZGs that we had last time. My name is Milica, for everyone new who's joining. I'm Developer Relations Engineer at ZK Verify. What do we do? We're verifying proofs, zero knowledge proofs, and I'm also doing my PhD in ZK. So I'm glad that I see so many people here, interested in ZK throughout this. Like, what is this? Like, third week for us that we're having this, and like, what did we have? Like four classes, two last week and two and the first week. And I'm so glad that I see so many survivors, right? People who did not, just give up on it. And I think we're coming to the worthy part. Like, let's see some practice. Like, come on, like all the maths and stuff. The thing is, like, it's important to know all of that before you start writing ZK circuits, because then we're gonna have hashes or rank one constraint systems or grad 16 and Plonk, that can be an output of this workshop, that you should know what's behind it and why do we have it and why did we have the KZG and like how everything looked like. First of all, who tried KZG at home? I'm very curious. Wow, have some hands up. Nice. Was it difficult?
Yeah, I needed to check for something and go back to our video. But after that, yeah, I figure out. I think.
Okay, okay. I mean, it's a playful thing to do, so why not? Today we're gonna have code. Yes, yes, yes. All right. Thing with Circum is it's not as any language that you might tried before. So, maybe I will ask you guys, have you tried programming before? Does anyone in the group have tried programming before? You have your own GitHubs, etc. Okay. So what did people tried programming in? So what languages did you try? Can you tell us?
I have done Python programming, the basics, C, C++, and Python. Yeah.
Mm-hmm. Mm-hmm.
For me, Solidity and TypeScript.
Perfect.
I started with C.
For me,
Yeah, go, Miguel.
TypeScript also, Solidity, Go, and Python.
Bravo.
I
Uh,
started with C.
Myself as well, Rust and TypeScript.
Super cool.
I started with C family. Then I learned JavaScript, TypeScript, a bit Solidity, and yeah.
Oh my God, I have someone who started with C programming language
Yeah.
like I did years ago.
Yeah, my school is so strict about it. We need to learn C. I actually can code assembly too, so it's just terrible.
Yeah, my teacher in high school, we started with Pascal.
Oh, really?
Yeah, yeah, it was fun. But it learned us the basics. So I see that predominantly we see high-level languages such as Python or TypeScript, Rust, etc. So it's important you tried something before you see Circum, because Circum is a bit it's a bit strange when you're coming from the regular, let's call them the regular languages for programming that we use, because it's not really a programming language per se, and we'll see why. Okay. So what is Circom, right? It's not a programming language, but what is it then? It's a hardware description language. Okay, it might sound a bit confusing, but it looks like a bit like electronics on a board. If someone have ever seen like all these wires, in electronics, usually something it's like a green board with a bunch of wires and a lot of details and components. That's how I sometimes see Circom. And I started my career in electronics. So it was very, for me, it was more intuitive than maybe for people who just had programming on their unis or they started with software development. But for me, I started with wires, like with with and also with the digital electronics where you have zeros and ones. So that's maybe the analogy that we can have here. Um, yeah, the Circum works with wires and gates. So similarly to what you have on one electronic board, is that you have wires that like they're kind of like signals, like the electricity or the voltage as we call it, right? It depends. Like you can have the currency, the current, and you can have also the voltage that can come and like trigger something in the specific circuit. And since Circum is describing zero knowledge circuits, we will have these wires that are kind of inputs, signals, and gates. It's similar to nodes, that something is happening at that point in that, let's say, electronic circuit, that either you will have let's say the amplification of signal, or you will have a gate that would open something, that would signal that something is opening. After it, some other circuit. So yeah, let's see how it looks like. I promise it's less complicated than electronics. And all the amplification circuits that we had, I promise it's less complicated. And instead of having the voltage and the amperes, we'll have zeros and ones, which is more predominant in digital electronics. So yeah, to have right, to work with circuits, we need to have a certain set of rules. So for us, we need to have a rule that we're working within rank 1 constraint system that we're going to see later, and finite fields. We had talked about finite fields, but we didn't talk before about rank 1 constraint systems. And we'll see what that is and why does Circum work only with rank 1 constraint systems. Basically, what you can think of as an R1CS, I've written some analogy that it could be like it's a set of IKEA instructions. I suppose that most of the people have seen the IKEA and like assembled something from it. So Circum is you describing, let's say, a wardrobe. Let's say like I want a mirror wardrobe with some glass shelves, and there is everything that you want to describe with some hangers, etc. But the R1CS, or rank 1 constraint system, is the exact step-by-step instruction booklet or whatever, like instruction manual that we got, that would say like attach this nail to this shelf, and and then you will get like laid out shell. So like a plus b equals to c. It gives out some output. Well, as let's say the snark that you have had, if I'm not mistaken, last week on Wednesday, snark systems, that would be like the factory that can actually verify right quickly through the booklet or through the instruction set without even building a wardrobe. So it's some kind of cartoonified explanation of how can you think about R1CS. But yeah, we're going to see examples as well, just not to petrify you in the beginning. Yeah, to speak a language this time it's not a natural, it's kind of a programming harder description language. We need to know the words, so we need to know about signals. Those are our variables in programming. In software engineering, you would see them as variables. So you're working with some values, right? Or some intermediary values, or input or output values. So for Circom, we would have input, output, and we can have intermediary signals as well. And they're usually not specified. They do not have intermediary next to their name, while as to be something to be considered input or output, they need to have those words described next to them. Also, we're gonna have operators, right? So we have like, it's like, I see like signals as the words, while operators as the verbs, because it tells you like, okay, do the assignment between values or make a constraint. So these are the two verbs, to say so, that we will use later. So these are the assignments. These are all the operators that we have, and you will see like how do they look like. There is value assignment and value assignment plus a constraint generation. They make difference between how does this arrow look like. One will have like one dash, like one dash in a level. The other one will have two equal signs. So it's the difference in what can we think of as in programming languages that you guys already had, is that value assignment would be seen as copying the value, while as value assignment plus a constraint generation would be referencing. Hatun, you must know this from C language, right? The referencing and the copying difference. But there is also in other languages the same thing. But that is like the crucial difference is that when you enforce a constraint, you are making sure that if something changes in the circuit, you will see the output of it, and it will actually be bonded, it will be tied. And if someone is trying to change something, maybe the evaluation will not be there anymore. So that's for you to ensure that everything is played by the rule of the circuit that you wrote. Then we'll have, there is a constant expression, the linear and quadratic, meaning that you can have multiple values as well. So yeah, constraint and the two operators. Yeah, I don't know. Have you ever seen, like, I think we all did in physics, right? In elementary school, the first Kirchhoff's law. So what does that guy say? It says that he says that the sum of all the currents leaving a node in any electrical circuit is always equal to 0. because Circom is a hardware describing language, we will have the same rules. And you can always write constraints based on that, because everything that comes to one node minus everything that leaves will be equal to 0. And let's say you want to multiply two values and you will have the output. If you multiply two values minus the output, you want to subtract the output that you had, you will end up with 0. And that's a law that persists in Circom too. So how do we also, like, when we talk about Circom, we can say that with normal programming, we'll have, okay, like take two numbers, add them, and return the results. But with Circom, we will have, I want to enforce that output one, the output in general, let's say it's outputs, called only that, is input one plus input two, and any assignment that does not satisfy this will be incorrect. It will be invalid. Okay. Okay, so yeah, like this is one of the circuits, not a Circom circuit. But actually, you can see that, this is how it persists, like the Kirchhoff's law. And what we're going to see in Circom is that, value of every of these knots or nodes, electrical or electronical nodes, it needs to be 0. And so we're going to have less complicated now than these ones, but yeah, this is maybe how it was based on when someone was designing Circom. I'm sure of it. Yeah, so zero-sum game persists here too. So knots or nodes, they look like this. So let's say that our input is x1 and our other input is x2, and we will have a constant as well. This is how we are building a circuit. So like you can do it with other polynomials. Now we know what polynomials are, right? And how to work with them. But also what's needed is also a flattening of the polynomial before we go, because we're working with the R1 constraint system. We need to do the flattening of the polynomial. So let's say we cannot do x1 to the power of 3, our input signal power to the power of 3, just like that, and make a constraint, because it wouldn't work in Circom. And we'll see why. But basically, you need to simplify it to, let's say, like inputs of, to say so, for level 1, even with constants. If you're adding constants before a certain input, you need to add them in this manner as well. So how do we do it? So it says like x1, we see a plus sign. So x1 is the input signal, x2 is an input signal. So in first iteration, we would say like, okay, so our intermediate signal that we have after this first plus, it will be x1 plus x2, right? The other one would be x2 plus 1, right? And then we can multiply two signals that we got as intermediary. Okay, so questions so far?
So is this called as a Merkle tree, or this is how a Merkle tree is made, or this is something else?
You can think of it as a sort of an arithmetic tree,
Okay.
because because I want to simplify it as much as we can. So it's I took some examples that could be, familiar with everyone so far with, just the nodes and stuff. But yeah,
Okay.
yeah, it's not immediately related to Merkle trees. Other questions? No? Yeah, okay. That means that it's understandable. Okay. Yeah. Let's try out something. Let's try out the flattening of the polynomial. So if everyone has notebooks and pens and paper, right? I mean, let's try it out. Like we had here with the zero-sum game. We can have it here like 3x to the power 2 plus 2x plus 5. So we want to ensure that we can prepare something that can satisfy, let's say, the branches and the nodes as we have in the before example. And I would like you to show us how does your tree look like. I'm reading the comments. Someone asked, we don't have to worry about the constant here, right? We can add it. We can add it. Yes, always two inputs for an operator.
My tree looks ugly. It was not really pretty as in the previous example.
Show us, Hatun.
It is not so.
Why? It's pretty.
But yours were like a really triangle one.
Well, it's called a balanced tree.
Yeah, mine is not really balanced. It's like
Mine is worse. Not even. Only the idea. Unreadable.
kind of similar, I think. Yeah, like this.
It reminds me of searching the tree, and then like you have balanced tree and
Oh, algorithm classes. It was like a
yeah,
It's
I loved it. I loved it.
I really hate algorithm classes because it was so hard and like it's my right now I'm experiencing the trauma again right now.
I have posted last week's photo with one of my colleagues from Milan. Uh, we visited Politecnico di Milano, and people commented that this building gives me chills.
Yeah, probably if you share my university too, it would be so traumatizing to me too. Like,
I agree, especially when they ask like something like that, but implemented in C language. Nice.
we are writing assembly on paper, so nothing beats.
I had exams on paper. Yeah. I remember those days when they would just like take a picture and do the optical character recognition. And if you forgot some bracket somewhere, like you just failed. They
Yeah,
don't even look at it.
exactly the same. I always says that it's come from, Soviet Union idea in Turkey. So it's just,
Yeah, especially when they give you the math books and then you have to learn another language. Like fine, make it like double hard. Yeah, so else wants to show their tree. Okay. But yeah, hot in the tree that you shown is actually correct tree because it cannot be balanced. Let's see. Oh, someone shared the paper. Nice. Okay. Uh, let's see. Okay, so most of you guys have figured out how to do flattening, and that you cannot just like give it the polynomial, but you have to do operations bit by bit. Good that we do not have bitwise operations here. It would last. Okay, so this is how it would look like in Circum. This with what we had here is like what Circum needs to go through to come to that point. This is how it can work out. So we need to have the intermediary signal, and then we can work out with the output. Okay. Let me see, like, is someone excited for the programming part? We can actually go now to zkrapl.dev because thanks to Xerox Spark team, we do have zkrapl. So we do not have to install the entire Rust tool chain and compile everything. So just to write some zero knowledge programs in Circum. So yeah, um, one of the other things that I want to emphasize here that with zero knowledge proofs, you're not writing just like a code to be executed like Python. You're writing constraints that must hold true like equations between variables. So it's like math, but programming math. Okay. All right. Shall we go to zkrapl.dev? Let me see if I have it. Yeah, let's try it out. So what I can do is I can write some examples with you guys. I'm not sure if everyone has their own computer right now, but I want all of you to be able to write it out. Let me check. I can share output from the remarkable this time, like with the last time. Oopsie. Let me share the remarkable output then. Let me check. perfect. Okay. Back to Zoom. Okay. Check. Stop sharing this one, share another one. Okay, everyone sees my remarkable input. Super cool, people see it, very nice. Just give it a bit more bold lines. Okay, you should be able to see the remarkable input right now. I have prepared some easier examples than we can do with we go with some examples like with commitment as well. So let me check what can we have here. So first of all, we should open zk-repl.dev. So it's looks like this. Okay. Is everyone able to see it? Okay, the majority says yes. Let me check chat. Why don't we have to do the intermediate? Why can't we use x times x directly? It's because of the rank 1 constraint system. So, oh, thank you, Rocio. Thank you. Very kind of you to add the link to the chat. So why don't we use just x times x directly? Because for writing the arithmetic circuits that later get compiled into rank 1 constraint systems, we'll need to use for proving systems R1CS to generate zero knowledge proofs, and rank 1 constraint systems they work with only you can think of it like that tree that we had, that we can work only with 2 inputs at a time. So even if it's like let's say like we can work with you can work with polynomials of higher order as well, but you need to flatten out the polynomial. It's in a way you can think of it as not having an interface to work with higher order polynomials. Let's say, it doesn't understand anything more than our flattened out polynomial. Okay. Okay, so this is the link that we want to open. I want you guys to try it out yourself and try sharing your screens to see what you got from your result. That's why I want to use pen and paper on my side, so that you want to try it out yourself and see how it goes, right? So we're not putting everything on a silver plate, but today is a bronze plate and you have to work it out yourself a bit. So let's try out an example of multiplying 3 inputs. Let's try that one out. So once you open zkrepl.dev, you would have you need to delete the example that we have there, with it's usually inputs of 5 and 77, I think. So we want to have our own example. So let's say it's you need to write the pragma, Circom, was it 2.126, I think. And then we're gonna call it the template. Template multi 3. Okay. We're gonna have our input signals. This is usually what we have for comments, the sign, so we're gonna have it just for explanations. Signal, input, in 1. Signal, in 2. Signal, input, in 3. 1 output signal. Signal, signal output out. So far, everyone following? Okay. Let's use helper signal. Signal, let's call it, okay, out 1. And we're making assignment and constraint in 1 times in 2. And then out signal, the real output signal, will be output 1 times in 3. It's the end of our template. This is the multilinear comment seen in many languages. It says input is in 1, let's say it's 3. So it's the JSON format that we have here. Input 2 is 4. Okay, just like a normal column. Input 3 is 5. And it's the end of input star dash.
Should we write this in the ZK report.dev?
Yes, 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 yes. So we have seen it here, we have template and we're gonna have components, for example, and you can think of them sort of something we had like a class in object-oriented programming. That might help you. But yeah, I would like to see, guys, your outputs with us.
I have a question in the So the signal output is out, and then in the helper signal we put signal out one.
Mm-hmm.
What is the one, or is that like, is there a space, or it's just out one?
It's just like out one. We can call it helper or whatever. It's intermediary signal.
Okay.
It's not considered an output,
Hmm.
no, but yeah, it helps us and rename it to something. What would you like us to rename it to?
Okay.
Mm-hmm. Okay, someone shared. Check. Rosia shared the output. Perfect. Check.
And how do we run the code?
Command plus enter. That's how we run it. Oh, we have dropped something out. That's why you see the input output like that. Let me put it in. Yeah, I don't know how I skipped it, but it's we need to have the main component as well. So after, I don't know if you see it, after here, right? We should have, after this curved bracket, we should have component main is multi 3. Try it out now how to, please. Mhm. Ariel, you need to have input signals. You need to have values so that you can calculate it. Mm-hmm. Mado asks, why do we have the arrow constraint instead of just two equal signs. So why don't we have that? Why do we have the assignment? Because we need to, if we just had comparison, we would just like check in that point, like if the two values are equal. But here we're using the assignment. So what would they had it with the outputs and this immediately signal, we're connecting them. That's why we have it. Yeah, Verilog. Okay, Hatun, did you try adding this one line that we dropped? Does it work?
Everything works well.
Okay. You got the same output other people got? Perfect. Well, congrats, guys. You have written your first zero knowledge circuit. Super cool. I'm so proud of you guys. We have come to this point where after all the maths and all the, hashes and games that we had, like now you're actually entering the field of writing circuits and understanding them. So what did we show here is the multiplication of three inputs. So let's say that we had this there's three inputs. We cannot just make the constraint just like that, but we needed to have actually some intermediary signal, some helper signal that we can call it like I don't know, who wants to give a name to the helper signal? Maybe we can change it. No one, anyone? Okay.
In the comment section, people says temp and med.
Which one?
In the comments, could you say temp? We can use temp or said med. Rocio, I don't know how to read this one. X. So I don't know.
Ox.
Sorry.
Auxiliary.
I don't know what's that mean. I'm sorry.
Yeah. It's a helper. Yeah, let's call it temp. It's a good one. Okay, now
yeah, maybe why can't we put directly in 1 times in 2 instead of temp? Like I didn't get it.
Because of the rank 1 constraint system. So rank 1 constraint system says that you can work up to quadratic, but you cannot work with let's say x to the power of 3 or x to the power of 4 or anything above the quadratic. That's why. What's the difference between the helper signal and var? So the initial example has var. We can use that as well. There's no issue. Okay, guys, any questions so far? Okay, do you guys want another example? Yes, Saura?
Yeah, in the link which I opened, I could also find Poseidon mentioned. So can you put some light on Poseidon is?
Yeah, I think it's used for hashing. I happen to have an example with hashing as well. And if you guys want, we can help. Yeah, do you guys want, then we can use another example with that, with Poseidon hash, where we can see, let's say, some guessing or whatever that that will work with Poseidon hash. Okay. Check if I can move this more. Okay, let's say because this startup initial example has Poseidon, right?
Yeah,
Yeah.
the link which I opened first, right? You see Poseidon,
Okay.
like it's
Okay, let me check. Maybe we can have something with commitments then. Okay, let's try out the templates with the hash. So let's try it out. Okay. Which one would be feasible to do within the time that we have? Okay. Okay. Well, let's check it out. Okay. So. Okay. Let's try guessing, but with commitment and see how it works out in the example of circuits. Let's try it out. Okay, so this should be a new example. So that means that once we run it again, I mean, like before you save it, you need to run it again. Otherwise, you will have the output of the previous one. Okay, we're gonna use for this. We're gonna use two libraries. One will be comparators. The other one will be Poseidon. This is how it should look like. Pragma, Circom, 2.1.6 for this example. Okay, everyone sees this. Check. For it, we'll need to include two libraries, Circom, lab, .circom. Okay. And another one. Let's try guessing some numbers. Let's see. So, what was the problem with the previous example? Yeah, you can use signal for intermediary signals. So that way, yeah, whenever something changes, it will not be a constant value. So it should have, let's say that in our example, we had input 1, input 2. So that intermediary signal will change based on input. So yeah, definitely we can use signals for that. Okay, In this example that I want to show you guys is this is where we want to have, okay, we want to guess a number. We're gonna have three inputs here. We're gonna have one for our guess, the other one for commitment, and the other one for a solution commitment. And yeah, let's try it out. This would be like one example that's closer to real life, to say so, circuit examples. So let's write that one down. Signal input, guess. Another one, signal input, solution. Third one, signal, okay. Input, solution commitment. And signal, output, answer. Okay, everyone following so far? Okay. Okay, so we're gonna use this component. The call is correct guess. And we're going to use is equal. This is something we're using from these comparators that you see on the screen. This library. Then we're going to have inputs because the comparators library are using their own functions to compare whether two inputs are truly equal. And to do that, we need to assign it to that function in a way, let's say like this function will have two inputs, and we will assign it as in the class that has its own variables within it. So we're going to assign two values and have an input to that class. You can see it, the library is called IDEN3. It's like this. This is the library that you can look for all of these child libraries that that you can see, like comparators, etc. That you can see how do they have two inputs, and now you don't have to. I mean, like you can write is correct guess, like is equal function. You can write it in your own circuit. But why are you doing that when we already have ready circuits for that? So we don't have to do that. But you can always check it and get inspired from what their engineers have made for us, that we can use it off the shelf. Okay, so to do the assignment, we're gonna say is correct guess dot in, and now we see that this looks like an array in most of the languages. So in the first index of the array, and it's 0 because we're programmers, right? Engineers. We're going to assign guess our signal input from here. Okay. For the other one, we're going to use solution. Then we will have component solution hash. That we took from Poseidon library and say you're going to be Poseidon solution hash. And yeah, guys, sometimes you will say dot in, sometimes you will see dot inputs. It depends on who created the library, so you always need to check how does it look like. It's not consistent throughout the circumlib. So we're assigning solution because we want to get the hash out of it. And then we're going to compare it. Solution hash dot out. So it's output. We want to make a constraint and check the equality with solution commitments. The answer, what would be the answer here?
I have no idea. I'm a bit lost.
Mm-hmm. Tell us, please.
Maybe D.
Same here.
Maybe is correct guess can be the answer. No.
Yes, we need an output out of that because we have put gas and solution both to is equal function, and we need to get an output based on that. So far we are checking if the two hashes to solution are the same, are they equal, and we need to see if then the gas and solution are comparatively equal. So yeah, it is correct. Gas dot output, dot out that we have. And with that, our template is done. For it,
Melissa,
yes, sir, yeah.
I have a question with component solution hash is equal to Poseidon 1. So what exactly this is comparing two hashes like the solution hash and the Poseidon one. It's the permutation of combination we are checking if this hash is right and wrong. So this line is doing the same work or is it something else?
So in this case, when you have component solution hash is Poseidon, or a component is correct guess, it means is equal. That means that is correct guess is inheriting everything from is equal library. So it's there's some noise. So it's in a way like instantiating a class in regular programming languages.
So your Poseidon is already a function or a class library that is already provided with this REPL day.
Yes, we don't have to build it. It's built for us.
Okay.
Okay, let's wrap up our example. We'll have here. Number.
America, also one question. The signal input solution commitment. Now, solution commitment is one word, or do we have a space between solution and commitment? Because while compiling, there might errors or warnings should pop up. I'm just trying to confirm whether solution commitment is one word or two different
Yeah.
words.
It's one word. Yeah, it should
One
be
word.
one word. Yes. Super cool. And we're gonna have input. Which ones that okay, I'll try scrolling a bit. So all of you can see. Gonna guess. Was it for? Let's say it's for solution. It's also for. And then we're gonna have solution commitment as one word. I'll give you a website where we can use Poseidon for calculating the commitment to 4, but it should end up with something like 0, and sorry, 9904, etc. But you need to write that down. Let me check which one is it. The website that we can use. For this one, it should be Poseidon hash dot. Let me check first. Right. I'll share it with you. What should be the hash part? Yeah, that's it. Yeah, it's at Hatum. This is the tool you can use for it. Yes, Kelly, that's it. That's the item tree library that we're using here. Yes, perfect.
Can you show a bit up the file to see the import?
Mm-hmm.
Thanks.
I have nothing changed while I created this example, but yeah, I can share with you how does Poseidon look like from within. Let me share it. Check. Okay, solution commitment. Hatun, I think you got it right. Yeah, looks like so. You can calculate it as well. You got like all of the artifacts, and you can use Grot 16 for that, and then you will have you will end up with some with one HTML page. You will end up with the with the other artifacts that can be used later for ZK verify. Suitable is number. Okay. Okay. Let me share something else. Okay. So do you see Poseidon Circum circuits here in Circum Lab? Hatun, do you see Poseidon Circum on my screen? Okay. I got the okay as in diving, like, yes, everything's good. Super cool. Okay, let's try to see, let's find comparators. Okay. So this is what we used here. So these comparators are like some basic functions that we are using in our, for example, is equal that we used, but there are multiple others as well. There are less than or less equal than, so you don't have to write all of that out by yourself. But let's say if you wanted, you could have used this one, but also you can use as zero as a function. So you remember when we were talking about how all the nodes need to be equal 0, right? This is how it works like. So we got two inputs, N1 and N2 in our case. And how the circum work, it says like, okay, what I will do is subtract one from the other, and if the result is 0, I'll deem it as equal. And that's how it works with zeros, and the zero sum game. We have it here. Okay, let's go to the Poseidon one. There are like different ones that you can visit here, like where was the other one that I wanted to show you? Okay, it's not here. But let's say this one. This is what we have used for Poseidon. Let me show you the exact function. Let me check. Okay, this is the one. Why did we have like Poseidon 1? Because it asks here for the number of inputs. And it will give you an output. So once you see like when we had like, okay, this, what would you have? Solution hash, right? So we used solution hash out, and that's what we got later for comparison. Okay. Bravo, Hatun. This is a perfect demo that you got. So we got our guess, our solution, and solution commitment. We generated a proof. Yeah. Okay, had everyone tried what we had here with this input with guessing the number for this example? Anyone had any trouble?
I tried, but yeah, I have trouble to make it work. I didn't really understand how we get the solution commitment hash.
How do we get solution commitment hash?
Yes, like had to paste it in the chat, but no, I know you paste it in the chat. So you send it. We don't have to generate it.
Yeah, let's say that you are like trying out a lottery and you want to know that, like, what the solution is to certain guessing, because you want to make sure that you are taking part in a fair game, that the person who's running the game, they need to make a commitment to it. So that's why.
Okay, and how did you get that number? Is the random one?
No, it's not a random number. That's why we used Poseidon hash library. So it's a hash of a solution calculated using Poseidon.circom library that we have here. So we used this one, this function here. So this template is what we used for, and that's for our internal calculations within the circuit. But how we got it is that let me check. So we have you can calculate Poseidon hash of a certain number online. I have posted a link in the chat, and then you can put it in as the input.
Okay.
Okay, let me check. So yeah, Q&A time, and let's stay in touch. I will be off for 2 weeks. But once I come back, one of the next lessons that we're gonna have with us as ZK Verify, I think it will be held by Arman, the one that will be teaching what ZK Verify looks like, whether we have architecture-wise, and then another one that will look like that will, we're gonna dive into practice on how to verify these zero-knowledge proofs. One of the things that we're also using is in our examples is this zkrapl.dev libraries that were generously created by 0x Park team. So, didn't have to install the whole Rust toolchain and everything that comes with it. So if you want, you can try it out and generate some. I think we also have some Poseidon. Yeah, we do have some Poseidon examples there. So it's docs.zkverify.io. I'll share the link with you guys. Okay. That's where we have the examples. And you can also verify the proofs, not only create them, because to actually make sure that your proof is valid, you don't want it to be right forged, and the other party needs to verify. Then you need to either write a smart contract every time, or you can use solutions like ZK Verify to verify it.
So you said that Arman is going to do ZK Verify session. So is this our last session with you?
I don't think so. I will have like the second one, the second of the 2 sessions, I think. Yeah.
Okay. So we're gonna see you one more time. I was a bit emotional, like, oh my God, is this the last one? But yeah, okay.
I hope not. And we'll see you guys in Argentina as well. But my colleague will be there for one session with you guys because I'm going on vacation.
Perfect. You really deserve one.
Thank you so much. I'm so happy for it.
Do we have any questions, guys?
All right. So please, when I downloaded the HTML, that's the grot 16, the input button isn't appearing why I'm facing this challenge if it's only me. Let me put a screenshot so you have a view of what I'm trying to achieve.
Are you sharing this screenshot in Telegram group or the chat, this chat or Zoom chat?
Thank you guys for the supporting words and messages here in chat.
I'm posting it in the chat.
Okay.
Let's check it.
Oh.
Yeah, also guys, you can try and play with like different let's say like different guesses and like still the same commitment, and you can see like either like change the guess or change the solution or like slightly change the hash and check how does it look like. So what are you trying to do here, John?
All right. What I'm trying to achieve is that was the second example that we solved, right? We received 3 inputs. So I tried to make mine 5 to receive 5 input and check if it's the same.
Okay, can you show us your
So
working?
this is the graph.
Yeah, this is the HTML page that was generated, I guess, with grot 16. But can you go back to the example then to see like how did you change the inputs?
Okay, so this the example. So I edit to receive temporary numbers.
Oh, this is the first example.
Yeah.
Okay.
Yeah. So that is what I did. Okay. So I created an array, right, which is going to receive an input of 5 digits.
Okay, nice. You're starting to play with it with different number of inputs.
Yeah.
Okay.
But I didn't understand why the input. You see, when Hatun downloaded her HTML file, she got the chance to input some digits. That's 44, right? To verify that, of course.
I
But
tried
I'm not.
maybe.
Yeah, I'm not seeing that at my end.
I use Plonk, by the way. Maybe it is something different. Yeah. And maybe you don't have the input signal in the band, but no, you have. I'm sorry.
Yeah, John, if you want, you can write me on Telegram.
All right. All right. Okay, so if you use Plunk, then that means I need to try Plunk because I used Grot 16. I guess that's the reason why I'm not getting that.
I think it's just the different example, but I can look into it later. Yeah, just make
All
sure
right,
like
all right,
you can tag me
all right,
and Ziki
all right.
verified that I'll
All
be
right.
there.
Thank you. Sure.
No worries.
Then, if you don't have any question, maybe we can finish the session.
I have a question.
Yeah.
Yeah. So Melika, this is more on the practical terms for developing. Basically, why would we choose Circom for uh, developing over Neuer or something? Or basically, like, can you give uh, the process why how it is, like what benefits Circom has, and why it is better than other ZKDSLs? I'm asking from personally right now because my team, we are building a gaming collective, so we're going to use it, as you're aware. So uh, I wanted to get an idea because we always have the dilemma where with my developers ask me, like, should we go with Circom or should we go with Noir or some other ZKDSL? So yeah.
Mm-hmm. Yeah, well, we're using Circum because I like to show, in this example at least, I like to show how things work on the low level, so that you can see, you will receive some errors, like if you try guessing with different number, or you try to do commitment on a false commitment to put it like the solution commitment in our example. So it's just like you don't need to use any of the preferred languages of mine. For me, it's usually like what is the structure of the team. Let's say if the team has a really good knowledge of Rust language, then I would definitely advise you to go with Noir because it's Rust-based language. But for me, like it's always per preference to the team. Circum is a bit more, let's say, raw, a bit more complicated. But yeah, like I think Noir is a bit more friendly for developers.
The benefits, like both are like it's about personal choice, right? It's not that one is has more advantage, like Circom has more advantage than Noir, because that's the route we are going with Noir. So just so from what you said, I understand that it's more on the team basis, right? You need to choose, not it can be anything. Circom or online.
And also like depends on your code base what you have. Like it's depending if you're starting a project or you already have some code base, depends on the seniority of your devs, and practically like basically it's about a team decision and the
Yeah,
team lead.
makes sense.
Yeah,
Makes sense. Thanks, Malika. If any questions, I'll get in touch with you.
sure.
Thank you. Thank you.
My DMs are open, so
Mhm. I believe there's no other question. Thank you very much for everyone that come here and give their time. Thank you very much for your effort, Melissa. It was my first time with Circom and it was really fun. And yeah, let's finish this session.
thank you very much for
Thanks.
inviting me and also for entrusting me with this very important ZK concepts.
Thank you very much for your time. I mean, a lot of hearts.
Yes.
Thank you.
Thanks, Malika.
Have good holidays.
Thank you so much.
Enjoy,
Bye.
enjoy your vacation.
I will.
So, yeah,
Bye-bye.
bye-bye.
Thank you, all of you.
Thank
Yeah.
you for your time.
You. Bye bye.
Bye.
See you. Bye bye.